If it is a triangle, what? If it is a triangle, what is our formula to find the area? 1/2 base times height. Okay, guys, I'm teaching. Yeah.
What if you made a deal with him if he cut his hair, he got like a straight C or B on the test?
No, we're not making those deals.
Okay, but if you pass this class, I will cut my hair tomorrow.
Trapezoid! Trapezoid!
I will get a buzz cut tomorrow.
Trapezoid, okay, I'm teaching.
No.
Guys.
Go ball.
Guys, I'm teaching now. So a trapezoid is 1/2 the height times base 1 plus base 2. And then a parallelogram, which is both a rectangle or a parallelogram, there is base times height. So B stands for base, and H stands for height. Yes, Corey.
But I like getting my hair fancily braided, so.
Yeah, then that might be hard if it gets cut short. Okay, when you're ready, flip to the next page.
I look real pretty in a brush braid.
All right.
It's like straight up.
I wasn't ready.
Okay, I will go back.
Spretta, you're doing great.
What's the formula for this?
That's the same as the parallelogram.
Depends on the last time that I brushed it. Like, if it's the next day, probably about like 10 minutes. If like, again, it depends on if I throw it up in a pony and just like let it stay in the pony.
They autumn bound for Christmas this year.
Like an hour long.
Well, she had another box my mom got
Really?
for her grandma did. All right, guys. So, surface of a prism using nets. So please pay attention to this. We are going to find the surface area of a prism using nets. So what this shape is here is a triangular prism. Do you guys see how this is a triangular prism? It has two triangles that are parallel. It's not a pyramid. It doesn't come to one point. So there's a lot of letters on here. There's an A, there's an H, there's a B, and there's a C. So what this is saying is if you unfold your shape, you have its net. And you can find the area of each piece here. Do you see how we have area of each of these pieces? So you can find the area of each piece to find the total area. So what is surface area? Surface area is equal to the sum of the area of all the faces and bases. So what that means is that you can use a net and find the area of each face and base and add them together. We're going to have to know, you guys, sometimes you're going to have to know what the nets are. And add those together. So that's what that is saying here. Some of the times we will give you that, some of the times we won't. So it'll be like the practicing that will get you into that. That's why I brought the magnetiles in so that we could look at the pieces and then visually help you guys out a little bit more. Just because I know some people are more like visual learners than others. So it just kind of depends where you're at.
So more or less, this is the same unit as last one, but like more complicated.
That, and we're going to add volume to it, so there's going to be a little bit more. Hey, I'm recording.
That's why I said it very quietly.
Okay, surface area using nets. So right now, we have a square prism. So what this is saying here I'll do it with the same colors.
Yeah, you were doing it with all different colors. I was like, whoa, Miss Brady's getting wild with it today.
No, I just was trying to make sure you understood which were the rectangles and which were the squares. Okay, so we have a square prism. It's a square prism because two of the sides are just squares. Do you see if I were to fold this up, it would create a square prism here? These are your squares. So it's saying if we take that and unfold it, what are each of our pieces going to be? Well, this is the net for it. Do you guys see how they just put them like this? It doesn't matter where those are at. So if these are all 6 here, then what are all of the lengths here? These are all 6 here. So we'll say 6 centimeters, 6 centimeters, and 6 centimeters. If this is 12 centimeters, what is each of the lengths here on the rectangles? Okay, so we are now going to find the area of each of these shapes. What shape do we consider a rectangle and a square? And how do you find the area of a parallelogram? How do you find it? Base times height. So we're just going to do base times height over and over again. So area equals base times height. Well, 6 times 12 is? So if that's 72, that means that this is?
72.
And this is?
72.
And this is?
72.
Okay. And then to find this area, again, we're using area equals base times height. So 6 times 6 is?
36.
So if this is 36, then?
That's 36.
This up here is 36. So what do you think we're going to do with all those pieces now? Add them together. So I have 36 plus 36 plus 72 plus 72 plus 72 plus 72. So really, you can type this in as 2 times 36 plus 4 times 72. Why can I write it that way if you don't want to do it the other way? Do you understand why you can do that, guys?
Yes.
Okay. I don't care which way you do that, but just so you guys are aware. So go ahead and tell me what that is when you add those together. Did somebody else get 360, multiple people?
Yes.
So 360, it's talking about area, so that is centimeters squared. I am not 100% sure. I'm sure we'll have some of the regular polygons, but I'm not 100% sure. Okay, so if we were to take this,
Oh. Shut up, I'm learning.
Can she do it? Can she do it?
I doubt it.
She is looking like she's probably going to be able to do it.
Okay, so if we take what we have on the board there, it looks like this. So this is 3 and this is 4 down here, right?
Yeah.
So that means that this is 3 and 4 down here, and each of these lengths here are 12. So if we go to unfold this, you're getting better, guys. If we go to unfold this, it will look something like that, right? So let's draw the net of this. So I'm going to draw my 4 rectangles. So we already said that this is 4 here, right? And this side here is 3. So we have to be really careful here, guys. We have to be really careful here. Do you see how this is 4 and this is 3? And these are all 12? So these are going to be different lengths here based on this. So I can write on these. But if this is 4, then this purple one here is also... Do you see how those are lined up? So this is also 4 here. But let's be careful. If we fold this up, this side here is 3. So really this side here is also 3. Do you see how it's different? It's not the same all the way around here because it's not a square. It's a rectangular prism this time. So this is 4 here. So if this is 3 on this side here. So which one of these yellow ones, the first one or the second yellow one, will be 3? If we fold this up, it will be this one, right? Because this is the 3 here. So this will be 3, which means that this one here will be, do you see how this is the top of the box? Right? This is your top here. It will be right here.
Yeah.
So that one is 4. So do you see how this can be hard to visualize? You guys see how that can be hard to visualize? And that's why I'm kind of bringing these into you guys here. So we have, let's look at this here. This is 4 by 3, which means that this is 4 here. This is 3 here. These are 3, and this is 4. Do you guys see that? And we said that each of these lengths is 12. So you guys really have to be careful when you're labeling your nets. Okay, so we're going to find the area of each of these. How do you find the area of each of these? Base times height. So we'll do 3 times 4, which is 12. So this is also. So this is 3 times, what are we multiplying 3 by? Be careful, what's this length here? Aren't all of those 12? So we have 3 times 12, which is 36. We have 4 times 12 here, which is 48. And then we have 3 times 12 again, right? So that's 36. And then 4 times 12, which is 48. Okay, so we add all those numbers together. So I have 12 plus 12 plus 36 plus 36 plus 48 plus 48. So that's 2 times 12 plus 2 times 36 plus 2 times 48. It doesn't matter which way you want to look at it. What'd you say? 192 units squared. Sophia. Because this isn't a square base this time, it's a rectangular base. So this side here, which is 3, is touching this side on the net. And this side is also 3, so that's touching that side. And then the base here and the top part are 4 and 4. So that's why. Do you see how it's different when you unfold it? Okay. So what type of pyramid or prism do we have here? What did you say? It's a trapezoidal. If I can find the triangles that I want.
Shut up, dude.
Okay, so we have a trapezoidal. Stop talking. We have a trapezoidal prism. The problem with this is that the tiles are not the same length. So, you have a trapezoid, just act like they're the same here, that has rectangles coming off the sides, here and here, and then creates a base on the bottom.
So you just swoop in. Alright.
So the base is much fatter than the other sides.
Miss Brady, this is truly a valiant effort on your part.
Thank you. I'm trying. I still need 2 more of those triangles.
Using
So is how you passed your driving test.
Guys,
what?
respect. Okay,
I'm not
so
gonna offend him.
you have a trapezoid here on both sides. They don't make rectangular ones. I need to find them. So we have a trapezoid here. So when this unfolds, if we're looking at the net, it will look something similar to that, but better. So let's talk about this. So I'm going to draw my trapezoid. And off of my trapezoid, I have its lower part there that it's sitting on, which then creates another trapezoid. And then off of the two sides here, I have two more rectangles to make the walls. So those are not all the same size, are they, guys? No, which makes this problem a little bit harder. So first of all, we have a trapezoid here that has a height of 1.5, a base of 4, and this part here is 2. What? I am. I just realized that as I wrote the 2 down. There's another one off to the side here. I realized that, Madison, as I was writing too. I was like, where does that 2 go to? Because I didn't have a top to it. Do you guys see I didn't have a top to my trapezoidal prism? So that means that this is 1.5, 2, and 4. It then tells you that these lengths are all going to be 6. I'm going to guess that it's pointing to this being 3. So we have these are 3 here because they're congruent. So these are 3. So question so far before we continue to label this. Where does the 3 line up with? Which sides does the 3 line up with it? Is it the first, second, or third one here?
Second.
Second and the?
Third.
Third. The second and third both have 3s here. So what is the length here on this one here? Think about when this gets folded up. Where is this going to end up?
On top.
On top. What is the top here? 2. So this is 2. Yeah, so like if we fold this side up here, that will go with the slant sides, right? This one, if we fold it up, will go on the slant side. So this is going to close the top up, right? So as we set this up, it's going to be on top of the trapezoid. Do you see that? Okay. So how do you find the area of a trapezoid? Good.
Is there going to be a help sheet for the test?
I'm pretty sure yes.
How early can we get that?
I don't know. 1/2 of 1.5 times 2 plus 4 is what we get here, right? So what do you guys get when you put that in your calculator? Oh, sorry.
I think I'm going to light up my boards when I get my
Paycheck, you want me to make you an ice rally?
I'm good.
Alrighty.
All right, guys, what do you get when you do 1/2 1.5 times 2 plus 4?
4.5.
4.5. So if this trapezoid is 4.5, then...
That trapezoid is
Yeah, we don't have to find that one as well. How do you find the area of some rectangles here? We do base times height. So the other ones are just base times height, right? So we have 2 times 6 here, which is?
12.
We have 3 times 6 here, which is?
18.
We have 6 times 4 here, which is? And then we have 3 times 6 here, which is?
18.
So I do 4.5 plus
Turns out-
4.5
When Corey got his license, he
Plus
also got
12
a calculator and played
plus
with his brain.
18 plus 24 plus 18.
That one's fun.
So stop.
What?
Just stop.
It's always roasting.
Stop.
Me.
Both of you. Okay. So what do you get when you do 4.5 plus 4.5 plus 12 plus 18 plus 24 plus 18? Somebody confirm with Brandon. You got 81?
I trust Brandon. He's pretty smart.
81 centimeters squared.
You trust Brandon, Brad?
Yeah, but I also type things in calculators wrong sometimes, so that's why I just want to make sure we're all on the same page. Okay, questions on that so far before we move on to the next page? The never-ending packet.
There's just 2 lessons in here?
No, that's the one lesson. Okay, so we have a triangular prism here. So I have a right triangle here. Do you notice that we don't know this side here? Are we going to need to know that? So what can we do, Hannah? So we get to use our 2 squared plus 12 squared equals c squared to find that length. Let's round to 4 decimal places when you take the square root, please. Yeah, we'll make it less rounding errors. 12.1655. Okay, so we know now finding this is 12.1655. Sorry. All right, yeah.
Is that right?
Mm-hmm. Yeah. What'd you say?
How did you know you needed to know this side?
So let me show you why. So if I were to draw the net here, I have a rectangle here, right? Another one here, and another one here. Do you agree with that, Tucker? With that net?
Yeah.
Okay, the two sides that I know here are 2 and 12. So this is 2 and this is 12. And then I know that these are all 8 here. Do you guys see how that's what I know so far before doing the Pythagorean theorem? So do you see if I fold this up, this one and this one align here. So this is 2. Do you see that?
Yeah.
But if I tried to fold this side up, I have no clue what this length is here, right? Because I don't know what the hypotenuse's length is. So that's why I knew I had to do that. Because I visually looked ahead. Does that make sense? Are you sure? Did you say no or yes?
Yeah.
Okay. You could draw the net first and you could look at this and say, wait, I don't have enough information to tell me what that is. Does that make sense? If that makes more sense to you guys, maybe you guys need to draw the net first and say, wait, if I fold this up, I have no clue what this is because this isn't marked yet. And that might be a reason to trigger it for you guys. Okay? So we have a triangle, which is 1/2 base times height, and a rectangle. I don't know why I decided that triangle should be that. Okay. And we have a rectangle, which is just base times height. So what is our base and our height in the triangle?
12 and 2.
So we do 1/2 of 2 times 12, which is 12. And that is what our other triangle is, too. And then we just do base times height. So we have 2 times 8, which is, and we have 12 times 8, which is, and then somebody else needs to do 8 times 12.1665, oh, sorry, too many sixes, 1655. I'll put that in parentheses instead so it doesn't look like that's our multiple decimal points. 97.324? All right, now you guys get the privilege of adding those all together. 12 plus 12 plus 16 plus 96 plus 97.324. Did I get all of them? I think I did. And what do you guys get?
233.324.
233.324? Agrees? Millimeters squared. Okay, last question here, I think, before we get into volume. Yeah. Last question here before we get into volume. Okay, it says that the surface area of a cube is 864 square inches. Find the length of the lateral edge. A cube means that all of your sides are congruent. And how do you find the area of a cube, or just a square, I guess? What do you know about your base and height, though, on a square? They're congruent, so it would be like side times side, right? So to find the area of the lateral, or the surface area of this, we do side times side and get one of them. And what would you have to multiply it by? How many are there? Isn't there 6 sides in a cube? So if you find the area of 1, can't you multiply it by 6 if they're all congruent?
Yeah.
So we know that the surface area is 864 square inches. So we can do 6 times side equals 364 because there's 6 congruent squares in a cube and each of the sides are the same, right? What's side times side?
Why 364?
Did I write it wrong? It's 864.
I have a question.
Just don't know how to write things correctly, Tucker, that's why. What's up?
Why is it 5.5?
That's S times S. Side times side. We don't know what the side lengths are. That's what we're trying to find. So side times side is... This is actually side squared. So we divide both sides by 6. And we get side squared equals... Is it 146?
144.
Okay, close, but wrong. All right, so I take the square root of both sides, so I get each of the sides is 12. And it's a side length, so it's just 12 inches. It's not squared. All right, questions there before we get into some volume now? Huh?
What are the 6 cubes?
There's 6 sides in a cube, and they all are the same size. So side times side is the area of the face, and there's 6 of them that are the same, so that's why we're multiplying it by 6.
Okay.
Does that make sense?
Yeah.
Okay. Other questions you guys might have? All right.
So is that
Yeah.
more like a triangular pyramid or something? Would it be like
You couldn't necessarily do it then. The only reason you could do this problem is because everything's the same. Okay, so that's the only reason that worked, is because we can say that the side lengths are the same. Or else you'd have way too many missing variables going on.
Brennan, get off the phone.
Okay, volume of prisms. Volume equals capital B, which stands for the base area, times the height of the whole entire solid. So let's understand what that's saying here. First of all, volume fills up your shape. So if I'm finding the volume of this, the reason this works is if I'm even just looking at a cube, if I look at a cube like this was, if I find the area of the base and I continue to stack it on top of each other, getting the height, do you guys see that that's the height as I keep stacking? If I keep stacking, I will eventually get the height of the whole entire cube, right? So then we can put the cube around it, and that is the volume of the cube, right? Do you guys see that? So that's why in volume you find the area of the base and multiply it by the height, because essentially what that's saying is you're stacking the area of the base over and over and over again on the height. Does that make sense?
yes?
Okay, so let's talk about this. For a rectangular prism, this would be your base. You would find the base area here, which would be B times H, and you would multiply it by the whole entire height. Do you see that we would just be stacking that over and over and over again to get that makes up that height? And that's why this is, you can barely see that, this is your height. I'm hoping I have time to go between. Yes, that's the goal. The triangular prism. The base is the 2 parallel sides. So you're going to find the area of your base, which is 1/2 base times height, and you're going to stack that triangle over and over and over again up the height of the prism. So this is your big B here. This is your big B here. This is your big B here. Base area. So for a cube, it really doesn't matter what you choose for your base, but you would do a big B base area of base times height, and you're going to stack that over and over and over again to get the height. Oh, you guys will love the hexagonal ones. This is when trig will come back in. As if it's not hard enough, right? So you would find the area of this base and multiply it by its height. All right. All right. So what are we going to determine is our base on this one here? Which one are we going to say is our base?
The bottom one?
The bottom here?
Yes.
So our base area, we're going to find that first, is base times height, which is 18 times 16. Very good. So what is 18 times 16? 348, you said?
288.
288.
This is why I always get different people. And what is our height then? What are we stacking our height as? 8 is going to be our height. So it's stacking that over and over and over again up the 8 centimeters. So to find the area, we do the base area times the height. We found our base area to be 288 and our height to be 8. So, sorry, what did you say? And this is volume, guys. So, how do you measure volume? Area is squared, perimeters to the first power. What is volume? It's cubic, right? You talk about like the cubic space it fills up. So it is to the third power. So centimeters cubed. All right. What is our base on this side? What is the shape here?
The bottom one?
It is a trapezoid. So we will be using the fact that this is a trapezoid for our base area. And to find the area of a trapezoid, we do 1/2 height times base 1 plus base 2. Okay, so we have to know what our height is. What is my height, Landon, of the trapezoid?
The height is 7 centimeters.
The height of the trapezoid, only the trapezoid. That's the height of the whole entire thing.
4 centimeters.
Nope, be careful. Height goes from one base to the other. So it is.
12 centimeters.
I think that's a 2, so just be careful. So that's 2 is our height. What is our base 1 and our base 2, Bryce? 4 plus 10 is also up top. So since this is 10, this is 10, right? Since the height here is 2, the height here is 2. So our base area is just 14. Which number up there is our height? Which number up there is our height that we're going to be stacking that trapezoid over and over and over to? Do you see how if we stack it up the 7 centimeters here, that will get our volume? So that is our height. So we do our area, our volume. Why am I saying area? Did I say area over there? Guys, sorry. You might want to change this to B, not an A. So our volume is our base area times the height. Our base area is 14, and our height is 7. So that is 'What'd you say? 98, what? Is that what you said? 98 centimeters cube. It's cubic volume. It's filling up a space. All right. What is the base of this prism here? What are my two parallel sides? The triangles are my parallel sides. So we are going to be finding, so the sides that are parallel are your bases.
Aren't those two though?
No, those are not parallel. Those are meeting at a point. That means that they hit.
Oh.
Do you see that? So parallel means they'll never meet. So the two parallel sides, so they have to be both congruent and parallel to be our bases. Do you guys all understand that? So we have to find the base area of a triangle. Well, we need 1/2 base times height. Do we have both the base and the height? No, we have the base but not the height. But we know that it is a right triangle. So what can we use? We can use the Pythagorean theorem. So I'm going to use b squared, or so 9 squared plus b squared equals 15 squared. So why did I put the 15 squared on the other side of the equal sign? Because that's your hypotenuse, right? And c is your hypotenuse. You're trying to find another leg there. So 81 plus b squared equals 225. Is that 144? So that other side length is 12. So now do we have our base and our height? Yeah. So we have our base area is 1/2 of 12 times 9 is 54. Good. Okay. So what is our height for this one? What is our height? What are we stacking over and over and over again? Not 12. We're stacking the triangle over and over and over again to meet it at the other side, right? Do you see how you're trying to meet this triangle with the other triangle? And to do that, it has to follow this way. So your height here is 10. So we do volume equals the base area times the height. My base area we got was 54. My height is 10. So that is 540 feet cube. It's volume. Be careful. All right. Find the volume of this. So first of all, we need the base area. The base area here is this here. So that is 5 by 4. I'm sorry, we're finding x. So our base area is 20, and our height is what? Be careful, what are we stacking over and over again to meet the other side? What is our height of the other length here?
4.
It's not 4, we've already used 4.
5.
Okay, it's x, thank you. So this is 5 by 4. That is our base area. We are stacking that rectangle over and over and over again along this line here. Do you see that? We're stacking it over and over again to get to the other side. So that is this length here, which is x. We know our total volume is 128. So we have 20x equals 128. So what is 128 divided by 20? What is it?
6.4.
So that is 6.4 inches. You guys are going to hate the next page. I'm sorry. As if this isn't hard enough, we're going to throw a pentagonal one at you. One second. Okay. Last two. What are our base area? What are our bases here? This is kind of a hard one to see. Where are our bases here?
6.
Okay, so the bottom is not our base. There's nothing parallel to this, is there? What are the two things that are parallel, Ayana? The triangles are the things that are parallel. So our bases are the triangles. I know, you think bottom, but you have to think of parallel, and I get why you guys do that. So we have to do base times height. The problem is this happened again. Do we know all of our sides?
No.
No, so what do we have to use? So we have a squared plus b squared equals c squared. So we have a side length of 12. So we have 1/2, 12 times 5, which is our base area of 30. Okay, guys, we can do this right this time. You are stacking this triangle over and over and over again to meet the other side. Which length is making that stacking happen?
5.
Who said 3? Thank you, Paige. You said 5. So 3. Do you see if we stack this triangle backwards, it's following this length here? You can always tip your triangular prism on its bottom to get that. But that is a height of 3. So area equals, or not area, volume equals base area times height. So that is 30 times 3, which is 90 meters cubed. Okay, guys, ready? Let's all take an inhale in and an inhale out. Are we ready for some trigonometry here? Guys, do you all notice that our base is a pentagon? Does that look familiar to you guys from your last test? It's not leaving you. All of our sides are going to be 6.
We didn't learn this. I wasn't here when we learned it.
Yeah, me neither.
Me neither.
That's why I didn't get it right on the list.
Okay, moving on. If this is 6, what's half of 6? 3. How many degrees are each of the angles in a pentagon? I think it's 108. Let me look it up. I think it's 54. Let me just make sure of it. So that's 3 times 180 divided by 5. Yeah, it's 108 for each of the angles. So that is 54 degrees here. I'm breathing in. So I'm going to pull that triangle out. I know this is 3. This is 54. And we have a height here. What trig function are we using? So we're doing tangent of 54 equals h over 3. This is never leaving you guys. It will after this year. Don't worry.
Let's get 54 degrees.
So we know that all of the angles in a pentagon are 108. We talked about the n minus 2 times 180 over n last unit. And then this is cutting that angle in half, so half of 108 is 54.
How many pieces do you want to have?
Let's do like 3 or 4. I don't really care. Let me just do this. So 4.1291. Okay, so this is that same thing we did last unit. So now we find the area of that little triangle. 1/2 of 3 times 4.1291. What do you guys get? What do we get? 6 point what? 193. Is it 36? It would be 37, whatever. Something of that nature. This is only one triangle. How many triangles are in a pentagon?
5.
10. So this is 619.37. That is the big B for us. We found big B. Base area. What are we stacking over and over again to get to the other side? Our height is 15. So now we can do 619.37 times 15. And what do we get?
619.
Did something go wrong?
No.
Okay, I'm just not good at moving decimals over. So, guys, this is just 61. It's not a huge difference. So it's 61.937. 61.937. So 61.937 times 15 is what? Thank you, Tucker and Brandon. I dropped my stylus. Can you say that again? 900?
Yeah.
29.
0.0.
Did anybody get anything else? Okay, so this is centimeters cubed. And that is the lesson there.